So here we're going to look at solving systems of linear equations using Gaussian elimination. There are three types of elementary row operations. There are swapping two rows. This can be expressed using the notation with a double arrowhead. For example, we can swap row 2 with row 3. The next is multiplying a row by a non-zero number. For example, row 1 equals k times row 1, where k is some non-zero number. So for example, row 1 is equal to row 1. Adding and subtracting a multiple of one row to another row. For example, row 2 is equal to row 2 plus 3 row 1. In the end, after completing our elementary row operations, there are three solutions that we need to know. We can get any one of them after completing our row operations. We have no solution, we have infinitely many solution, and we have unique solution. Unique solution is when we have upper triangle, and what's happening here is that if it's in terms of x, y, and z, the first column represents x, the next represents y, and the third represents z. This is the first leading value, and this will represent us finding x. This is the second leading value, and it's actually the first leading value in the second row. So this is the first leading value in the second row. The next, this is the third leading value in my third row. It is actually the first leading value. So in other words, this is the first leading value in the first row. In the second row, this is the first leading value. And in our third row, this is our third leading value. To find this, we are going to look at the third row. This is the same as saying 1z, which is the same as saying z is equal to -1. So we start off by saying that this is a coefficient of z, so we can say z is equal to 1. This is going to create an equation, the second row. So I'm going to have y, which is the same as 1y, minus 5z equal 8. We know z is -1, so we have minus 5 times -1 equal 8. This becomes positive 5. So carrying it over, y is equal to 8 minus 5. So y is equal to 3. First row will become an equation. So you'd have x plus y minus z equal 5. And we know that y is 3, z is -1 equal 5. So 3 plus 1, that's 4. So we're going to have x is equal to 5, take away 4, so x equal 1. So what's happening here is that each variable has a unique answer. It has a definite answer. So that's why it's unique solution, where we only have one value for each point. We can have infinitely many solutions, and this occur when we have all zeros in the third row. And what's happening is that, just as before, I can call this to be x column, y column, and z column. And this is the leading value in the first row. This is the next leading value in the second row. So since this is all 0, then we say z represents a free variable, let's say t. And what this means is that t can be any numbers. It's an element of real number. So that's why we say it's infinite, because it can represent any real number. Creating an equation for the second row, I will have 2y minus 3z, but z is t, equal 1. So therefore we have 2y equal 1 plus 3t, and dividing both sides by 2, we have y is equal to a half plus 3 over 2t. Now, it's infinite solution. As you can see, z is in terms of t, y is in terms of t, and that means x is also in terms of t. So we have this first row becomes x minus 7t minus 5 equal minus 5. So carry that over, x is equal to minus 5 plus 7t. So all values are in terms of t. And what this is saying is that whatever t is, we get an answer for x, y, and z. So we say that z represents any number, so we consider it to be a free variable, and y and x depends on the value for x. So therefore, we have infinitely many solutions. Now, the last solution that we look at is when we have no solution, and that's when you have 0 equal a number in the last row. I would say this is x, y, and z. I cannot say 0z equal minus 3. So there is no point of intersection. So therefore, no solution. Thanks for watching, guys. Don't forget to like and subscribe to my channel.